Welcome to the Explainer. Today, we're going to do something pretty fun. We're going to frame the entire economy as a giant, bustling kitchen. Together, we'll learn the absolute ultimate recipe for creating utility and satisfying human wants. When you strip away all those complex charts and the super dense jargon, economics is really just about how we take raw ingredients and turn them into things that make our lives better, easier, or honestly, just more enjoyable.
Okay, let's dive into this. Here's the menu for today's explainer. Section 1 is what is production. Section 2 is the 4 key ingredients. Section 3 is choosing the right recipe. Section 4, the element of time. And finally, Section 5, limits and trade-offs.
Section 1. What is production? Creating utility. Now, when you hear the word production, you probably instantly picture this massive factory with giant smokestacks, right? But in economics, it is so much broader than that. Production is simply the process of creating or increasing the usefulness, which economists call utility, of goods and services. So whether a big firm is mass-producing running shoes or a local chef is serving up a hot lunch, the ultimate goal is exactly the same: to create utility, or basically happiness, which consumers are more than happy to pay for. To really see how this works across the whole economy, let's look at these 3 types of production. Primary is the extraction of raw materials. Secondary is manufacturing. And tertiary is services. Think about your favorite chocolate bar. When a farmer grows and harvests the cocoa beans, well, that's primary production. When a massive factory processes those beans and turns them into a sweet chocolate bar, that's secondary production. And finally, when a trader or your local grocery store actually sells that candy bar to you, that's tertiary production. They all play distinct but absolutely crucial roles in the production process to bring you that utility. Section 2, the 4 key ingredients, also known as the factors of production. So, if production is a recipe, we absolutely need to look at the foundational building blocks required to make literally any good or service. To make sense of these somewhat dry economic terms, we're going to use a highly relatable pop culture lens, the movie Monsters, Inc. Think about it. In the film, they run this massive factory just to generate energy for their city. And this brilliantly illustrates our 4 ingredients. First up is land, which represents natural resources. Now, in Monsters, Inc., their natural resource isn't oil or coal, it's the physical doors to the human world and the screams they harvest from them. Second is labor, which is human effort and skills. This is your scarers, like Sully and Mike, doing the actual heavy lifting. Third is capital, meaning machinery and tools. This includes the physical factory building itself and those yellow screen canisters they use to store the energy. And finally, entrepreneurship, the organizing and risk-taking. That's Mr. Waternoose, the CEO, who combines those other 3 limited factors to try and generate a profit for the whole shebang. Now, looking at that list, I want to ask you a quick question that might completely challenge your everyday understanding of a specific word. Is a $20 bill considered capital? Take a second to really think about how we usually use that word in daily life. The answer in economics is no, absolutely not. Money is not a productive resource. As the economists love to say, you can't pound a nail with a $20 bill, and a warehouse foreman certainly can't lift a heavy pallet with a $50 bill. Money just facilitates trade. True capital actually consists of the physical machinery, the tools, the computers, and the delivery vans that are physically used to create those goods and services.
Section 3, choosing the right recipe or production functions.
Okay, so once we have our ingredients, our land, our labor, our capital, and our entrepreneurship, we need specific mathematical recipes to mix them all together. We start with the simplest recipe out there, the linear production function. This is a model where inputs are perfectly substitutable with a constant marginal product. In plain English, it means every single time you add a new ingredient or new worker, it yields the exact same increase in output. There are no diminishing returns here, it's just a straight, highly predictable line. To see how this looks in the real world, let's contrast that linear model with the Cobb-Douglas model. A linear function is a lot like a neighborhood lemonade stand. If one helper makes 5 glasses, adding a second helper adds exactly 5 more glasses. They are perfectly substitutable. But the Cobb-Douglas function? That's more like a complex tech company. Here, inputs like software engineers and computer servers actually complement each other. If you hire 100 new engineers but you don't buy any new servers for them to work on, you're going to get massive diminishing returns. In Cobb-Douglas, your inputs absolutely must scale together in specific proportions for the firm to stay highly productive. And then we have the Leontief production function. This is a model where inputs must be used in rigid, fixed proportions. This is literally the strictest recipe in the entire economic cookbook. The inputs act as perfect complements, which means there is absolutely zero substitutability. None. Let's compare variable proportions to these fixed proportions to really lock this in. A clothing factory has variable proportions, right? They can constantly experiment with a flexible mix of sewers, sewing machines, and fabric to find the absolute most efficient way to make shirts. But a fixed or Leontief model is like a very, very specific pizza restaurant. Imagine the recipe requires exactly 1 oven and 2 chefs to make a certain number of pizzas. If you go out and hire 3 more chefs, but you still only have that 1 oven, well, those extra chefs are completely wasted. You won't bake a single extra pizza because the proportions are rigidly fixed. Section 4, the element of time, short run versus long run.
So our chef or our entrepreneur definitely has options, but those options are heavily constrained by the clock. Now, short run doesn't mean a specific number of days or months. It just means a time period where at least one factor of production is totally fixed, and that's usually capital. You simply don't have enough time to build a brand new factory, forcing you to only change your labor. The long run, however, is a longer horizon where you finally have enough time to change absolutely everything.
When a firm finally reaches that long run and has the flexibility to expand their entire kitchen, they face what we call returns to scale. There are 3 scenarios here. Increasing returns means if you double your inputs, your output more than doubles. You basically get a huge bonus for scaling up. Constant returns means doubling your inputs exactly doubles your output. And decreasing returns, also known as diseconomies of scale, means if you double inputs, you actually get less than double the output. This usually happens because the firm has just become way too massive and inefficient to manage properly. Section 5, limits and trade-offs. Scarcity and the PPF. Let's zoom out from the individual kitchen for a second and look at the absolute limits of our entire economy's capacity. This brings us to scarcity, the defining rule of economics. We have limited resources to meet totally unlimited human wants. Consider a simple pair of denim jeans. The land to grow the cotton, the labor to sew it, the capital, it is all limited. Choosing to use scarce resources for those jeans means they absolutely cannot be used to grow food or manufacture other goods at the exact same time. Choosing to produce one thing always means leaving something else unproduced. Now, what's really interesting about this slide is how we can visualize this exact problem using the Production Possibilities Frontier, or the PPF. It physically maps out an economy's maximum efficiency and the trade-offs between producing 2 different products, like, say, skis and snowboards. Any point directly on that line, like A, B, or C, means the economy is using all of its resources perfectly efficiently. But here's the catch. To move from point A to point C to get more snowboards, you mathematically have to give up producing some skis. That curve is the literal visual representation of trade-offs. And that brings us to the ultimate reality of production. We only have so much land, labor, capital, and entrepreneurship to go around. Since every single choice to produce something inevitably leaves something else unproduced, I want to leave you with this. Look around at the goods and services you consume today. What is your economy choosing not to make in order to provide those for you? Think about it. Thanks so much for joining me on this explainer, and keep questioning how our world is put together.